Hello, I have good news and bad news. The bad news is finding stationary points without the equation. These problems make up the toughest exam problems. These are the hardest problems I come across, and they separate the state. They're typically the last questions on non-calculator exams. These pop up a lot. The good news is this is the last video for these 2 weeks, so if you're up to here, you're doing well. So the question is, I'll read it to you. Cylindrical cardboard postal tubes are made with the restriction that the sum of the length and the circular circumference are 120 centimeters. What should the dimensions be for the maximum volume? How are you meant to find that? It's barely giving you any information. Well, you have to make your own equation. You have to maximize that equation, and then you have to solve for the dimensions. A lot of steps here. Let's just make sure we know what all the words mean. The circumference is that around there. The length is that length across there. Alright, let's start with an equation. Well, we know the volume of a cylinder is given by pi r squared h. If you don't remember your area and volume formulas, grab an old textbook and memorize them all. If you want to do really well on the exams, you will need to know these formulas, all of them. You need to know things like, I'm going to give you a little list here, that the area of a circle is pi r squared, that the circumference is pi d, or that it's 2 pi r, that the volume of a sphere is 4/3 pi r cubed, that the surface area of a sphere is 4 pi r squared, that the volume of a cone is 1/3 pi r squared h. You need to know, that's just a few. You need to know the lot. There's more. So if that list looks familiar, good. If it doesn't, let me know and I'll find a list for you to get access to if you have trouble doing that. But we know the volume of a cylinder is given by this. It's also given us a restriction. It's given us another piece of information, that the sum of the length and the circular circumference are 120 centimeters. We know that the length plus the circumference equals 120 centimeters. Alright, what can we substitute into these equations? Well, the height of this cylinder is really just the length. So let's rewrite this equation as pi r squared L. And the circumference of a circle can be rewritten as 2 pi r. Alright, what we're going for here is an equation for the volume in terms of one variable. As soon as you get the volume in terms of one variable, you can solve this problem. Let's get it in terms of r. Well, let's solve for L here. L equals 120 minus 2 pi r. Now we can sub that into there. So V equals pi r squared, 120 minus 2 pi r equals 120 pi r squared minus 2 pi squared r cubed. Voila, there's your volume formula. In the previous video, they would have given that to you. They would have said, here's your formula, do the procedure and maximize it. They separate the state by challenging you to come up with the formula. I'm not pretending this is easy, and if you don't get it straight away, don't worry, we'll have plenty of practice on these. I'm telling you, it's worth getting down if you want to do well. Alright, well, we've got the formula, then we find the derivative. So dv dr equals 240 pi r. minus 6 pi squared r squared. So I've taken the derivative there. Well, we want to find out when it's maximum, so let's set the derivative equal to 0. Minus 6 pi squared r squared. And we can factorize. That's a good way to solve it. You could use a calculator for this question. So let's take out 6 pi r, and we're left with 40 minus pi r. Have I got that right? Yes. 6 pi, yep. Yep, that looks good to me. Alright, so now we can use null factor law. So for this part, well, either 6 pi r equals 0 or 40 minus pi r equals 0. So over here we have r equals 0. That's no use to us. What good is that? Has radius 0, so it doesn't exist. Alright, we have to look over here. 40 equals pi r equals 40 on pi, and the units are centimeters. Alright, that's the radius. We've got the radius, we need to find the length, and lucky we've got this formula here. So L equals 120 minus 2 pi 40 on pi. L equals 120 minus 80. L equals 40 centimeters. Alright, so have we answered the question? Almost. We need to write a sentence somewhere. We know that the length will need to be 40 centimeters. We know that the radius is 40 on pi centimeters. So we can say, we'll say the dimensions need to be length equals 40 centimeters. And I'll tell you what, it's pointed out the length and circumference. So let's find it in terms of the circumference to answer the question more accurately. We know that the radius is 40 on pi. So let's find the circumference. C equals 2 pi r equals 2 pi 40 on pi equals 80 centimeters. That makes sense. 80 plus 40 is 120. So dimensions need to be length equals 40 centimeters and circumference equals 80 centimeters. Alright, that's our answer. This is an introduction. We're going to come back to this. There's going to be a whole application task where you get to take it home and really think about this. So if you get the outline of what's happening, that's a good place to be at this point. And if you have been, thank you for watching.